you by thesis123.com. I learn and teach online.
Here's the next question, number 39. The saturation voltage of the ideal op-amp shown below is plus minus 10 volts. The output voltage V0 of the following circuit in the steady state is, we have A, square wave of period 0.55 milliseconds, B, triangular wave of period 0.55 milliseconds, C, square wave of period 0.25 millisecond, and D, triangular wave of period 0.25 milliseconds. Okay, so here we have our diagram given to us, and it's been said that it's an ideal op-amp shown. Now, what you have to do is look closely at the figure and see what type of op-amp it represents. Now, once you know which type it is, then you will be able to find out what kind of output waveform it produces. Now, this op-amp given here resembles an op-amp multivibrator, or more specifically, it resembles an astable op-amp multivibrator. Now, I have drawn the figure here of an astable multivibrator. So, if you see carefully, this general diagram of an astable op-amp multivibrator is exactly similar to what's given to us in the question. And one of the characteristics of an astable multivibrator is that it always produces a square waveform. So that rules out two of the options given to us. We can rule out option B and option D. So now we know that the multivibrator, the op-amp, produces a square wave. Next, we have to find out what the period is. So this is an astable op-amp multivibrator. And an important characteristic is that it always produces a square wave. Now, in order to find the period, we will have to look at the output waveform, and it can be found by the RC time constant of the two timing components here, R1 and R2. So, the feedback ratio given by R1 and R2 and the voltage divider network, it sets the reference voltage level. Now, using that, we will be able to find out the period. So, this is how we do it. First, we note down the expression of the RC time constant, which is beta. Beta is given as the ratio of R2 divided by R1 plus R2. Okay, so now we have the values of R2, R1 and R2 given in the figure here. Both are 2 kilo ohms. So this would be 2 divided by 2 plus 2. So beta is 0.5, 2 by 4, 0.5. Now, once we have the RC time constant, the next step is to write down the formula. There is a special formula here for an astable op-amp multivibrator. The time period T can be found by using this formula, 2RC ln of 1 plus beta divided by 1 minus beta. An interesting formula, helps to remember it. Please make sure that you note it down alongside the concept of an astable op-amp multivibrator. Now we have the values of R, we have the values of C and beta. So all we have to do is plug in the values and then solve to see what the value of T is. Now let me note that down here. So we have T is equal to 2RC ln of 1 plus beta divided by 1 minus beta. Substituting the values 2 into, Now R is the value right there on top, 1 kilo ohm. That measures 1 into 10 power 3 into, what was the value of C? I believe it was 0.25 microfarad, yes. So that's 0.25 into 10 power minus 6 ln of 1 plus beta, we just found it to be 0.5, divided by 1 minus 0.5. Now this entire part, 1 plus 0.5 divided by 1 minus 0.5, comes to 3. And let's see, here we have 2 into 2.5 to 0.25, and then 10 power 3, 10 power minus 6. So we will obtain 0.5 into 10 power minus 3 ln of 3. Solving it further, the value of ln of 3 is 1.098, and we solve this to get 0.55 into 10 power minus 3. Now 0.55 into 10 power minus 3 can be written as 0.55 millisecond. So our time period is 0.55 millisecond. So this is our solution. It's a square wave of period 0.55 millisecond. Well, I hope this explanation has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.